Good morning everyone. My name is Dr. Sri Ramya, Assistant Professor, Department of ECE from the ECE Institute of Technology and Engineering, Tadepalligudem. Today I would like to explain about the topic IoT Development Boards. So before going into the topic, let us see what is idea behind IoT. IoT is nothing but Internet of Things. Internet of Things means connecting the physical devices to the internet. Means one physical device is connected to the internet and the data is collected and the device and the internet communicate each other, and then the process and the task will be done automatically by the device through the internet. So we are having different types of applications based on IoT, like smart watches, home auto monitoring, and healthcare, and like agriculture. Even in industrial automation as well, robotics, we are using IoT from small scale to large scale. Small scale industries to large scale industries. But how these tasks could be performed without an hardware? So we need some hardware implementation to provide this all implementation. So for this we need IoT development boards. So we understood the purpose of IoT development. IoT, it collects the data from the sensors and processes it and sends it over through the internet. What is the key features of this IoT? Means it consumes low power, and it is wireless connectivity programming, and it can be connected to the number of peripherals like keyboard, mouse, and many other things. Okay, so to perform all these tasks, we need some IoT development boards and or some hardware platforms. So this is our today's topic, IoT development boards to perform a particular task in IoT. So coming to the key components, we are having to develop an IoT development board. We are having a key components like processor, memory, connectivity, input-output pins, as well as power supply. Okay, coming to the processor is the brain of any system. So it can control the operations and performs the task. Okay, coming to the memory, here we can store the information and processes the instructions. For the memory, we are having flash for program storage and RAM for runtime operation. And then coming to the connectivity, to connect the physical devices through the internet, we are having a connectivity modules like Wi-Fi, Bluetooth, Zigbee, Ethernet, and all to connect the physical device over the internet and transfer the information of a particular task. Coming to the input-output pins, we are having a general purpose input-output pins and pulse width modulation, analog digital pins, and so on to connect sensors and activators in the particular task to collect the information and to control the actions. And finally, we are having a power supply. In this power supply, it may be in the form of battery or solar or USB. So these are the key components which are required to develop an IoT development board. And coming to the next slide, here we can see the different IoT development boards. IoT development boards are in the form of microcontroller boards and in the form of microprocessor boards. Coming to the microcontroller boards, we use Arduino. And coming to the microprocessor boards, we use Raspberry Pi. These are the two types of IoT development boards which we are using in the IoT to perform a particular task in the hardware. So coming to the next slide, first we can see what is meant by Arduino basically. In the many educational institutions and researchers and engineers mainly used Arduino because it is very easy to use and it is an open source platform. So in this Arduino, we are having both hardware and software implementation. So we use hardware implementation in the Arduino board and the software implementation by using IDE environment. But we are having different types of Arduino based boards based on the application like Arduino Uno, Arduino Mega, Arduino Nano, Arduino Duo, and Arduino Leonardo. Okay, here in the Arduino Uno and Arduino Mega, Arduino Nano, and different Arduino boards are used based on the different IoT applications. So basically we use Arduino Uno board for the researchers. So researchers or the students commonly use this Arduino Uno board because it is easy to implement. So coming to the Arduino board, here we can see this is the Arduino Uno board. Here we can see the visualization of a Arduino Uno board. In this we are having a different types of pins and different types of components like see first we have already discussed that this Arduino Uno board, Arduino is works under the based on microcontroller. So here we are having a microcontroller. Here we are having microcontroller to control the particular tasks, and here we are having 16 megahertz crystal which is used to regulate the frequency of a particular task, and here we are having digital pins and analog pins. Analog pins is to collect the continuous data from sensors and the activators to perform or control the particular task, and continuous data can be collected using this Arduino analog pins. And coming to the digital pins, we are having a digital pins along with pulse width modulation pins. What is meant by digital pin actually? In the digital pins, we are having on or off conditions. Only on or off conditions, that is 0 or 5 volts on or off conditions we are having in the digital pins. But means LED on or off, or buzzer on or off, or in some cases motor on or off, we are having like that operation by using the digital pins on or off conditions. But if we use pulse width modulation pins, we can flip the on or off conditions 0 to 5 volts. On or off conditions 0 to 5 volts, we can flip the thousands of cycles per second. Then the brightness of LEDs may be flipped, and the motor speed should be increased or reduced, or then buzzer sound alert will be more or less. Based on this pulse width modulation pins, we can regulate the output of digital pins like LEDs and this buzzer and as well as DC motors, anything which we are offered in the particular task. And coming to the USB port to the computer, here we use, this is an USB port. In this USB port, we can directly connect to the computer, and here we have voltage regulator. This voltage regulator can regulate the voltage and can finally the reset pin. Based on the particular task, we can perform the Arduino Uno function. Finally, after performing or completing the task, we can reset the board and can be further we need to reset the pin, and further we can implement other task. Okay, next, coming to the next slide. This is the pin description which we have already discussed, that is USB, which can be operated both power and communication IDE, and barrel jack used for the power supply, and voltage regulator which regulates the voltage, and crystal oscillator which regulates the frequency, and reset pin to regulate the Arduino Uno, and 3-point V pin, and here we are having 2 pins of output to 3.3 pins, and 3.3 voltage pin, and 5 volt pin. So here, coming to the 3.3 pin, here the output can be regulated by using voltage regulator, and 5 volt pin, the output is from USB port. And coming to the ground pin, and we have ground and V in pin, and as well as analog pins, 5 analog pins which is used to seek the information continuously from the analog signal. And microcontroller, and as well as ICSP pin. This ICSP pin is used to is instead of USB in some cases, and power indicator, LED, and many other based on the application. Here we finally have transmitter and the receiver to receive and transmit the signal, and digital input pins along with pulse width modulation pins, as we already discussed in the pin diagram. This is the pin description of the IoT. See here, we can see Arduino Uno board. Here we are having different types of resistors, sensors, and here this is the connectors. These are male and female connectors which is used to connect Arduino board digital and analog pins to the breadboard directly. We cannot connect through the connecting wires. These are the connecting wires, male and female pins, which can be connected to the breadboard through this analog and digital pins. And this is an IDE environment, means this is a software used to write a program to a particular task performed by us, and this is connected to the Arduino board through the USB. Then when we have to write a program to perform a particular task here, and it can be run here, then we can see the output in the Arduino Uno board by blinking the LEDs or buzzers or and motor speed, etc. We can see by using this Arduino IDE environment. We can directly connect it to the Arduino board using USB pin. See, these are the connections which we have made from the Arduino Uno board to the breadboard using male and female connectors to the LED. Likewise, we have to connect, and then it is connected to the IDE environment. Then we can see the result. Up to now we have seen about Arduino Uno board, but we have discussed earlier that Arduino, not only the Arduino Uno, we are having different types of Arduino boards like Arduino Mega, Uno, Dio and Nano something, but here we can see about the Arduino Mega. In the name itself, we can see that Arduino Mega means which is used in the large industries. So here we are having, it operates in 5 volts operation, 5 volts, and it has 54 digital input output pins, and among them 15 are pulse width modulation outputs, and it provides 16 analog pins, and it has 256 KB flash memory for storing the program, and it is suitable for large projects like industrial control and complex industrial automation system, and as well as robotics. And coming to the next one, Arduino Nano. The name itself we can see it is a nano project. Nano, it is used in the nano projects which operates at 5 volts, and it has 14 digital input output pins and as well as 6 pulse width modulation pins, and it provides 8 analog input output pins, and it has 32 KB flash memory, and it has small in size which is used in the nano projects like IoT devices and wearable electronic applications. Coming to the Arduino Dio, we are using 3.3. It operates at the 3.3 volts, and it has 54 digital input output pins along with 12 PW pulse width modulation output, and it provides 12 analog inputs and 2 analog outputs, and it has 512 KB flash memory with 32-bit board which operates in the high speed. And Arduino Leon, it is operates at 5 volts, which is having 20 digital input output pins of 7 pulse width modulation outputs and 12 analog inputs and 32 KB flash memory, which is used to that requires a direct USB control without extra hardware. Okay, this is all about Arduino. Arduino means which is used based on the microcontroller board, because it needs the support of computer to run the program and execute the output. But in the case of Raspberry Pi, we already discussed that we use microprocessor instead of microcontroller. We use microprocessor in the board. So what is the difference means? Microprocessor means Raspberry Pi is like a mini computer. We does not require any computer to implement the particular task. Directly we can insert an SD card through the Raspberry Pi in the back of the Raspberry Pi board. Directly we can include the SD card, and there we can install in the SD card we can install the particular software. Then that can be used directly without involvement of computer. In this Raspberry Pi also we are having a different types of boards like Raspberry Pi Model B+, Raspberry Pi 4 Model B, and Raspberry Pi 4 Pi 0W. Okay, next these are the types of Raspberry Pi, and here we can see how the Raspberry Pi board looks like. In the Arduino, we are not having a port of Ethernet port, but here we can directly connect the Ethernet to the board. And here we are having a USB ports. In these USB ports directly we can connect the mouse and keyboard, and you can use like a computer. And here we are having audio jack, HDMI port, and in this audio jack we can include the earphones or the speakers. Then here we can listen the output, and here we are having a camera interface and audio HDMI video ports. So in this we are having a processor instead of controller, and general purpose input output pins we are having 40 general purpose input output pins in this Raspberry Pi kit. See, this is the general description of the Raspberry Pi kit which we have discussed in the board. So processor is the heart of the Raspberry Pi, which controls the operation and connected the device and handles all the required computations. So coming to the HDMI, it is used for transmitting video on digital audio data, and we are having general input 40 general input output ports and audio port also. Coming to the USB ports, it is directly, we have already discussed that keyboard and a mouse can be connected directly to the USB ports, and SD card is placed in the Raspberry Pi kit, and Ethernet is directly can be connected to the Raspberry Pi kit, then power supply along with the camera module and display. And coming to the next slide, this is the general input output pins. Here we have told that we are having general input output pins. We are having 40. Among them 4 are power supply pins and 8 are ground, and general purpose analog and digital purpose pins are 26, and I2C connections are 2. So we are having total 40 pins in general purpose input output pins based on the our requirement to perform a task. So this is the Raspberry Pi 3 Model B+. This is the other type of Raspberry Pi kit. In this, the features may differ, like it is having 1.4 GHz 64-bit and with 1 GB SD-RAM, and it includes a gigabit Ethernet over USB 2.0, and it has built-in 2.4 GHz SS and 5 GHz Wi-Fi and Bluetooth, and it offers 4 USB 2.4 ports and supports HDMI output, audio jack and camera display, and it is used for general computing, IoT server and robotics. Likewise, the remaining 2 also we are having the different features to perform the task. This Raspberry Pi 4 Model B and this Raspberry Pi 0W, we are having a different frequencies and different USB ports for for desktop replacement and AI project server, and also for the lightweight automation portable gadgets. So these are the different types of Raspberry Pi boards, and finally we can see the difference between the Arduino and the Raspberry Pi. In the Arduino, we have already discussed that we are using a microcontroller which is used in the IDE, which is connected based on IDE environment, and here it consumes the less power, and here in the Raspberry Pi we directly include the SD card, so this acts as a mini computer. In this we require the computer's help, but in this Raspberry Pi we no need any computer's help. Directly we can install the software in the SD card and it consumes more power. Thank you.